Hey there, science fans. Let's talk about labs. Labs are where amazing discoveries happen, but accurate results are super important. That's where calibration comes in. Imagine a scientist measuring ingredients for a new medicine. If their scales are off, the whole experiment could be messed up. Calibration makes sure our tools are accurate. It's like tuning a musical instrument. Just like a musician needs their instrument to be in tune, scientists need their equipment to be accurate. Calibration is essential for all sorts of lab equipment, from thermometers to microscopes. Without it, we can't trust our results. And untrustworthy results? That's a big no-no in the science world. So how do we calibrate equipment? It's like following a recipe. First, we check the manufacturer's instructions. They're like the recipe steps, telling us exactly what to do. Then we verify accuracy. We compare our equipment's readings to a known standard. Think of it like checking your watch against an atomic clock. If they don't match, we adjust our equipment. Finally, we keep records. We write down when we calibrated the equipment, who did it, and any adjustments made. It's like a science journal, tracking our calibration journey. Now, let's dive into metrological traceability. Sounds complicated? Don't worry, it's simpler than it sounds. Basically, it's a system that links our lab measurements to national or international standards. Think of it like a chain. Each link represents a step in the calibration process. The chain starts with the international standard and ends with our lab equipment. This chain of calibrations ensures that our measurements are accurate and reliable. Metrological traceability is crucial for many reasons. It helps us compare results from different labs, ensures consistency over time, and gives us confidence in our findings. Section 4. When traceability gets tricky, finding other ways to ensure accuracy. Sometimes metrological traceability isn't possible for certain methods. It's like trying to fit a square peg in a round hole. But don't worry, we have other ways to ensure accuracy. We can use things like control samples, replicate measurements, and statistical analysis. These methods help us detect errors, assess variability, and ensure our results are reliable. Remember, science is all about finding solutions. Even when traceability isn't feasible, we can still have confidence in our findings by using alternative approaches. Section 5. The importance of trustworthy results, calibration and traceability in action. Calibration and metrological traceability might seem like technical details, but they're vital for trustworthy science. Imagine a world without them. Medical diagnoses could be wrong. Environmental monitoring could be inaccurate. The possibilities are, well, not good. These processes ensure our results are accurate, reliable, and comparable. They're the unsung heroes of the science world, working behind the scenes to keep our experiments on track. Section 6. Wrapping it up, calibration and traceability for reliable science. So there you have it, science fans. Calibration and metrological traceability are like the dynamic duo of accurate measurements. They're essential for any lab that wants trustworthy results. Remember, accurate measurements lead to groundbreaking discoveries, life-saving medicines, and a better understanding of our world. And that's something worth striving for. Keep those instruments calibrated and those measurements traceable.